Hi everyone, today I'm going to discuss another type of mathematical word problems, the digit problems. And at the end of this lecture, you are expected to be able to solve digit problems following the Polya's four-step approach in problem solving. Let us recall that all real numbers are simply combinations of the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, and that the value of a number is determined by understanding the place value of each digit. Examples: 8 alone has a value of 8 ones, or we call it 8 units. 8 in 83 has a value of 8 tens. That means in number 83, there are 8 tens and 3 ones. So we can write this as 8 times 10 plus 3. 8 in 843 has a value of 8 hundreds. That means in 843, there are 8 100s, there are 4 tens, and 3 ones or 3 units. So 843 may be written as 8 times 100 plus 4 times 10 plus 3. Now, digit problems usually involve finding a two-digit number from or between 10 and 99. Or it may be involved finding a three-digit number. That means we will be looking for a number between 100 and 999. So this can be solved using variables to represent the tens, the hundreds, the tens, and the units digit, and using a mathematical model. So for a two-digit number, you can let this number be represented by 10x plus y. That is, if you will let x represent the tens digit and y for the units digit. So for convenience purposes, I usually, instead of using x and y, use t and u to represent the tens and the units digit. So my two-digit number is represented by 10t plus u. So if the problem involves the reverse of this number, the reverse of 10t plus u will be represented by 10u plus t. So take note, when we talk about reverse, say 83, its reverse is 38. So you just reverse the position of the digits. So for a three-digit number, you may let the digits, hundreds, tens, and units digit be represented by x, y, and z. So the three-digit number will be represented by 100x plus 10y plus z. Again, for my own convenience, I use 100h plus 10t plus u, where h, t, and u in here represents the hundreds, tens, and units digits respectively. The reverse of this number will be represented by 100u plus 10t plus h. Let us solve this problem. The units digit of a two-digit number is twice the tens digit. When the digits are reversed, the new number is 36 more than the original number. Find the original number. So using the Polya's four-step approach of problem solving, we start with understanding the problem. So in this problem, we are required to find a two-digit number. A given condition is that the units digit is twice the tens digit. Another condition is that when the digits are reversed, the new number formed is 36 more than the original number. Okay, so we continue with the second step, that is to devise a plan. And so since this is a digit problem, we make use in here of a mathematical model and the variable which represents the tens digit and the units digit. So we have now the two-digit number will be represented by 10t plus u, where T and U represents the tens and the units digit respectively. And since there is a mention in here about the reversed number, so we say the reversed number is represented by 10U plus T. We now proceed to the third step, which is to carry out the plan. In carrying out the plan, we write the equation based on the given conditions. So the first condition is that the units digit is twice the tens digit. So U is equal to 2T. The second condition is that when the digits are reversed, the new number is 36 more than the original number. So the reverse digit of the number is represented by 10U plus T, and this new number is 36 more than the original number. We now simplify this equation. We have 10U plus T equal to 10T plus U. So if you want to get rid of 10T plus U on the right side, we subtract both sides by 10T plus U, giving us now 9U minus 9T is equal to 36. We simplify further this equation by dividing both sides by 9. So we have U minus T is equal to 4. So that we are now ready to substitute the first equation, U is equal to 2T, in this equation that we give us now, 2T minus T is equal to 4. Simplifying further, we now have the value of T is equal to 4. So to solve for U, we go back to the first equation. So U is equal to 2 times T, which is equal to 4. And so we have now U is equal to 8. With this value of T equal to 4 and U equal to 8, that means the number is 10 times T, which is 4, plus 8, or this is equal to 48. So we proceed to the next step, which is to look back. Again, to look back is to make reflections or try to check if the obtained values will satisfy the conditions. So the first condition is that U must be equal, or the units digit must be twice the tens digit. So the units digit is 8. Is it equal to 2 times T, which is equal to 4? So when we simplify, 8 is equal to 8 is an identity. Therefore, the first condition is satisfied. The second condition is that the reverse digit is 36 more than the original number. And so when we substitute values, we have 10U is 8 plus T, which is 4. We try to check if this is equal to 10 times 4 plus U, which is 8 plus 36. So we have 84 is equal to 84. Since we arrive at an identity, that means the second condition is also satisfied. So having all the conditions satisfied, and so therefore the two-digit number is 48. Here is a problem. The sum of the digits of a three-digit number is 11. The tens digit is 3 times the hundreds digit and twice the units digit. What is the product of the digits of the number? So we make use in here of Polya's four-step approach of problem solving. We start with understanding the problem. So in the problem, we are asked of the product of the digits of a three-digit number. We're given a condition that the sum of the digits is equal to 11. Also, we're given that the tens digit is 3 times the hundreds digit, and also the tens digit is twice the units digit. So since this is a digit problem, we make use of variable to represent the hundreds, tens, and the units digits. So we have H, T, and U to represent the hundreds, tens, and units digit respectively. And then this three-digit number will be represented by 100H plus 10T plus U. The third step in our solution is to carry out the plan. In carrying out the plan, we are going to make or write the equations based on the given conditions in the problem. The first condition is that the sum of the digits is 11. So we have H plus C plus U is equal to 11. The second condition is the tens digit is 3 times the hundreds digit. So we have t is equal to 3h. Also, the tens digit is twice the units digit. So we have t is equal to 2 times u. So we now have in here a system in 3 unknowns. Now, if you know how to make use of your calculator, you can just manipulate the equation and immediately your calculator will give you the value of h, t, and u. So just to illustrate our another method of solving for the system, so we can use in here the substitution. That is, in the second equation, you can solve for h in terms of t, and in the third equation, you can solve for u in terms of t. That gives us now h is equal to 1/3 t, and u is equal to 1/2 t. Substituting h and u to equation 1, we now have 1/3 t plus u whose value is 1/2 t is equal to 11. So we are now ready to solve for t in here. You can immediately use your calculator or you can simplify this equation. So if you're going to multiply the equation by 6, that's the least common multiple of 3 and 2. That will give us now 6 times 130, that's 2t. 6 times c is 60. 6 times 1/2 t is 3t, that is equal to 11 times 6, which is 66. So further, we combine, we simplify. 11t is equal to 66, or t is equal to 6. So having this value of t equal to 6, we are now ready to solve for the value of h and the value of u. So therefore, we have now h is equal to 1/3 times 6, or that is equal to 2, and u is equal to 1/2 times t, which is 6, so 1/2 of 6 is equal to 3. So we therefore have the number, the 3-digit number, which is 100h plus 10t plus u is now equal to 100 times 2 plus 10 times 6 plus 3, or that is 263. Okay, so the last step in our solution is to look back. To look back is to check if the obtained values of h, t, and 2 and u will satisfy the given conditions. So we go back to the first condition that h plus t plus u is equal to 11. So we have 2 plus 6 plus 3. We try to check if this is really equal to 11. So having arrived at an identity, that means the first condition is satisfied. The second condition is that t must be equal to 3 times h. So is 6 equal to 3 times 2? We have now 6 is equal to 6. That means the second condition is also satisfied. And the third condition is that the tens digit must be equal to twice the units digit. So we have is 6 equal to 2 times 3. Yes, 6 is equal to 6, and so therefore, the three conditions were satisfied. That means the values of h, which is equal to 2, u, which is equal to 3, and t, which is equal to 6, are correct. So the 3-digit number therefore is 263. But you should take note, if you go back to the problem, this is not what is actually asked. What is asked in the problem is the product of the digits. And so therefore, that will be 2 times 6 times 3, and therefore this is equal to 36. Let us solve this problem. When a 3-digit number is divided by the number with digits reversed, the quotient is 3 and the remainder is 118. The hundreds digit is 2 more than twice the tens digit. Twice the units digit is 1 more than the tens digit. Find the hundreds digit. So we start our solution with understanding the problem. So we are asked in here for the hundreds digit of a 3-digit number. We are given a condition that when this number is divided by the number with its digits reversed, the quotient is 3 and the remainder is 118. Another condition is that the hundreds digit is 2 more than twice the tens digit. And we have another condition, twice the units digit is 1 more than the tens digit. We proceed to the next step, which is to devise a plan. So since this is a 3-digit number, we use variables to represent the hundreds, tens, and the units digit. And the number is represented by 100h plus 10t plus u. And since there is a mention about the digits reversed, it is represented by 100u plus 10t plus h. We now continue our solution with carrying out our plan. So in here, we are going to write the equations based on the given conditions. The first condition is when the 3-digit number is divided by the number with digits reversed, the quotient is 3 and the remainder is 118. So this is represented by, this is our 3-digit number and this is the digits reversed. So when when the original 3-digit number is divided by the number with its digit reversed, the quotient is 3. So we write now the quotient as 3 plus the remainder is 118. So we have 118 divided by the same denominator. Then we simplify the equation by multiplying the LCD, which is equal to this denominator, 100u plus 10t plus h. So we have now 100h plus 10t plus u equal to 3 times the LCD. We'll have 3 times 100u plus 10t plus h. And in the last term, the denominator cancels out, so what remains is 118. Simplifying further these equations, I'm going to eliminate some intermediate step. We go directly into combining similar terms. So we have here 100h, and this is 3 times h, that is 3h. So we have 100h minus 3h is 97h. 10t, and this is 30t. So we have 10t minus 30t is minus 20t. And u, this is 300u is minus 299u. Remaining at the right side is 118. So let this be our equation 1. The second condition is the hundreds digit is 2 more than twice the tens digit. So the hundreds digit is represented by h, and it is 2 more than twice the tens digit. So we have h is equal to 2t plus 2. Then another condition is twice the units digit is 1 more than the tens digit. So we have 2u is equal to t plus 1. And we can solve for u in here by dividing the equation by 2. That will give us now u is equal to 1 half t plus 1 half. So let us have now this one as our equation 1. This is equation 2. And this is our equation 3. So we are now ready to solve for the system of equations in 3 unknowns. So we substitute the value of h and u to equation 1. So that will give us now 97 times h. The value of h is 2t plus 2 minus 20 times t. So we have minus 20 times t minus 299 times u. So we have minus 299 times u, whose value is 1 half t plus 1 half. Again, to get rid of this fraction, we can just multiply the equation by 2. And simplifying, removing the grouping symbols, that will give us now 388t plus 388 minus 40t minus 299t minus 299 is equal to 236. So combining now similar terms, we have here all the terms containing t. 388t minus 40t minus 299t gives us 49t. And we have transposed this constant 388 and negative 299 to the right. Combined with 236, it gives us 147. So in this equation now, we can solve for t by dividing the equation by 49, giving us t is equal to 3. So since we already have the value of t, we can now solve in equation 2 and in equation 3 the value of h and u. So h then is equal to, from equation 2, 2 times t, which is 3 plus 2, and that gives us h is equal to 8, while u in equation 3 is equal to 1 half times 3 plus 1 half, and u is equal to 2. And so therefore, the original three-digit number which is represented by 100h plus 10t plus u is equal to 832. Last step of our solution is to look back, or we're going to check if the values that we obtained satisfy the given conditions. The first condition is that the three-digit number, when it is divided by the number with digits reversed, the quotient is 3 and the remainder is 118. So this is the number that we obtained, 832. And when we reverse the digits, it gives us 238. So we try to check if 832 divided by 238 is really equal to 3 plus 118 over 238. So combining the two terms at the right side, we have the LCD is 238. In the numerator will be 3 times 238, which is 714. Plus 118, we arrive at an identity, 832 over 238 is equal to 832 over 238. That means in here, the first condition is satisfied. The second condition is that the hundreds digit is 2 more than twice the tens digit. And so the hundreds digit is 8. We try to check if that is equal to 2 times the tens digit, which is 3 plus 2. So we arrive at an identity again. That means the second condition is satisfied. And the last condition is that twice the units digit is 1 more than the tens digit. So we have twice the units digit, which is 2, is equal to 3 plus 1. We arrive at 4 is equal to 4. That means the third condition is also satisfied. So having all the conditions satisfied, therefore, the three-digit number that we obtained is indeed 832. Again, take note what is asked in the problem is only the hundreds digit. That means the hundreds digit of the three-digit number is 8. I will end up my discussion in here. I hope by this time you can now solve the different digit problems. Thank you for watching.